All right, so we're doing the composition f of g, but it's of x plus 1. So it's kind of like when we plug in a number, we're just plugging in an expression. So there are technically two ways that you can do this. You could do the composition f of g and then plug in the x plus 1, or you can look at it from plugging in the x plus 1 first. So let's do it that way, just to kind of keep things more similar to the process with the number. Okay, so we're plugging x plus 1 into g. So I'm going to do my skeleton method here. Okay, I've got my g of x function, and I put parentheses instead of the x. In those parentheses, I put the expression that I'm plugging in, the x plus 1. I put that in there. Let's go ahead and simplify that. 2x plus 2, and then we subtract 3 from that. So it ends up simplifying to 2x minus 1. And then we're just plugging that into f. So let's take our f of x function and put our skeleton. Okay, we've got 2 parentheses squared plus 5 parentheses minus 12. Put the 2x minus 1 in parentheses. Okay, same as before, I answer this question a lot, and it's okay that I have to answer it, but let's just make it clear. You've got to raise the 2x minus 1 to the second power before you multiply by the 2. Order of operations. Exponents come before multiplication. So the 2's got to hang out in front. Foil that. 4x squared minus 2x, so minus 4x. Negative 1 times negative 1 is positive 1. Distribute the 5. Don't forget about the minus 12 on the end. Distribute the 2. Go ahead and combine the minus 5 and the minus 12. And then final step, combining like terms. Negative 8x plus 10x is plus 2x. 2 minus 17 is negative 15. Okay, so it looks complicated, it looks intimidating, but it's really not that bad. Let's do another one. Let's do g of f, so reversing the order, and that expression looks a little different. We've got negative a over 2, so let's check out and see what is a little different about this one. So we've got g of, so we're plugging, let's see here, trying to keep my color coding going on here. We're plugging negative a over 2 into f. So write down your skeleton, put your parentheses there, and we're putting negative a over 2 in our parentheses. Okay, we're plugging that into our f function. Everywhere we've seen x, we're putting negative a over 2. Let's simplify. When you square a fraction, you square the numerator. Negative a squared is positive a squared. 2 squared is 4. Square the numerator and square the denominator. 5 times negative a over 2, let's just go ahead and write that as negative 5a over 2. Look at it as turn 5 into a fraction, 5 over 1. Multiply the numerators. 5 times negative a is negative 5a. 1 times 2 is 2. Okay, one more simplifying step here. Simplify that 2 over 4. So 2 times a squared over 4 is a squared over 2. All right, now we got to plug that whole thing into g, which is not bad because g is just 2 times minus 3. We need to distribute the 2. So the 2's cancel. We just get a squared. Distribute the 2. The 2's cancel. We get minus 5a. 2 times negative 12 is negative 23. And so we get a squared minus 5a minus 27. Okay? And that should be your final answer. So kind of funny. We start with a fraction that we were plugging in, and then we end up with all whole number coefficients, but it works out that way because of that multiplying by 2. All right. Before we do the worksheet, I've got one more example I want to show you. Flip your paper over one more time. This is called finding the difference quotient. This is something called the difference quotient. So for each function, we're going to find f of x plus h minus f of x over h. So the difference quotient is this expression right here. That is the difference quotient. So a little bit of composition work going on here. F of x plus h. So we are plugging x plus h into our f of x function. So we've got negative 2. Replace the x with x plus h. So we're introducing an extra variable in here. So just follow me and let me know if something looks weird. So distribute the negative 2. We've got negative 2x minus 2h minus 7. That's as much as we can simplify that expression right now. So the difference quotient says take f of x plus h, that's what we just found, minus f of x. F of x was the original expression. Now because of that minus, I need to put that expression in parentheses because I need to apply that negative. And it's all over h. So let's do some simplifying. We've got negative 2x minus 2h minus 7. Distribute the negative. Plus 2x plus 7. Negative 2x plus 2x cancels. Negative 7 plus 7 cancels. So we've got negative 2h over h. You can also cancel those h's. So this one simplifies down to negative 2. Let's do it for a quadratic function. Okay, so we have f of x. We need f of x plus h. Remember, we have to FOIL x plus h squared. We got to FOIL it. So we get x squared. The outside gives us xh. The inside gives us xh. So we have 2 xh's. And then h times h is h squared. If you need to write that out to see it, that's fine. Distribute the negative 4. So minus 4x minus 4h. And then we got a plus 7 on the end. It would be great if we could combine some like terms. We don't have any like terms. Nothing has exactly the same variable expression. So let's put this into our difference quotient formula. So we take that expression we just found, and we subtract the original expression. And it's all over h. Just to save myself some time and space in writing, I'm going to distribute that negative right here so that I don't have to rewrite everything. So we have negative x squared plus 4h, or excuse me, plus 4x minus 7. So let's see here. We can cancel the x squares. We can cancel the 4x's. We can cancel the 7's. So what are we left with? 2xh plus h squared minus 4h. That's it. Over h. Now, in that numerator, Do those terms have something in common? Yes, they all have an h. Let's pull that out. 2x plus h minus 4 over h. We can cancel those h's because we were able to factor that h out of the numerator. So our final answer is 2x plus h minus 4. Now, this is not something, this is one of those kind of random topics that I throw in there because it's related to compositions of functions. This is not something you will be tested on. I'm not going to test you on it. I haven't even given you any practice problems on it, but this is something for those of you that will take calculus later on in life. This will look familiar. Okay, this is something that will come up, a process that you will have to do. So I just wanted to expose you to it before you get to it in that more advanced class. Okay.